Yes, students, at 9th class level, we are going to discuss the chapter work energy power. So, the terms work, energy, power, this will hear in daily colloquial language, but technical meanings are important. We have to drop out the literal meanings of I am planning a work, boost the secret of my energy, power filled candy. This kind of words we hear in daily life that are not technical. So cell in biology is different from cell in physics. Cell in pocket is different from cell in a police station. So same words may have literal meaning in languages like Hindi, Telugu, English, in subjects like physics, biology and economics. So the language point of view meanings are called literal meanings. Subject point of view meanings are called technical meanings. So now how do you define work done by a force? Suppose there is a mass and you apply a force and displace it. Then we define work done by a force as product of displacement and force acting in the direction of displacement. So if we keep force parallel to the displacement, then we can multiply both of them and get the answer. Force will be measured in newtons, displacement is measured in meters, newton into meter is a joule. So work is measured in joules. But in general, in reality, technical meaning is this. So if force is inclined at an angle theta to the displacement, then cos theta will come, cosine of angle between them. What is cos theta? At 9th class level students don't know because it is cos theta, tan theta, trigonometry is introduced in 10th class. But you can remember cos theta is equal to cos 0 is equal to 1 if f and s are parallel. So if I keep it parallel, the angle becomes 0. In that case, cos theta will become cos 0 is 1. Just by heart this for time being. Next, note this one. Never use the word called work done by a man, work done by a machine. This kind of words are meaningless in physics. Better you can use the word called work done by force applied by man. So this force is important because work is done only by force in physics. So without the word force or displacement, work loses its meaning. Instead of using the word work done by man, use the word called work done by force applied by man. Similarly, work done by force applied by machine. But better to avoid the word man and machine because force is important. Therefore, work is done by forces. If you are a 9th class student and you don't know trigonometry, better to by heart some cos theta values for different values in degrees, time being. What are they? Sorry for disturbance here. Cos theta for 0 degrees, cos theta for 30 degrees, cos theta for 45 degrees, cos theta for 60 degrees, cos theta for 90 degrees. These all are positive values. Cos 0 is 1, cos 30 is root 3 by 2, cos 45 is root 2 by 2, cos 60 is 1 by 2, cos 90 is 0. By heart these values. Next, add 30 to this. 90 plus 30, 90 plus 45, 90 plus 60. Then 90 becomes 120, 135, 150 and 180. Then this half, this is minus half, this is root 2 by 2, this is minus root 2 by 2, this is root 3 by 2, this is minus root 3 by 2, this is 1 and this is minus 1. These are the values need to be by hearted. That means whenever cos theta is acute 0 to 90, before 90, it's called acute angle between force and displacement. Work done will be positive because force is positive, displacement is positive. When you take magnitude of them, mod of them, cos theta will decide the sign. So acute angle cos theta is cos 0, cos 30, cos 45, cos 60, cos 89. All values you can figure out in calculator. They all will have positive values. Beyond 90, 91, 92, cos 120, cos 135, cos 136, cos 150, cos 180. Obtuse angle because force will be acting like this, displacement will be in opposite direction. Work done by that force will be negative because mod f and mod s will be positive, cos theta will be negative. And for the specific value called cos 90, that means force is applied right angle to displacement, then cos 90 will come, cos 90 is 0. So positive work tend to increase speed or kinetic energy, negative work tend to decrease or speed of kinetic energy. That is, if you apply force in the direction of motion, it increases the speed. If you apply force opposite to the direction of motion, it will decrease the speed. If you apply force perpendicular to direction of motion, it turns the object but it will neither increase or not decrease the speed. So work done by force is positive for acute angle, work done by the force is negative for obtuse angle, work done by the force is 0 for right angle. Positive work tend to increase speed on kinetic energy. Negative work tend to decrease or kinetic energy, speed and kinetic energy. Zero work will not affect the speed, but it affects the velocity. Now, let us understand in which cases work done is zero. Go to the basic definition. Work done by a force is magnitude of force, magnitude of displacement, and a cosine of angle between them. So, work done by a force will be zero if force is not applied. For example, in outer space, object is moving, it is displacing. Where there is no gravity, no force is applied on it. In that case, force applied is zero, but still body is moving. Even in that case, work done is said to be zero. Next, if displacement is zero, you are trying to push one wall or a big rock, unable to move it. So even though you applied force, displacement is zero, so work done is zero. Next, cos theta is zero. For example, some circulating object is there. You are applying force towards the center. Say you are rolling a simple pendulum round and round. Tightness is towards the center. Displacement is happening along the tangent. Angle between them is 90 degrees. So cos 0 is 90. So either force is 0 or displacement is 0 or cos theta is 0. Cos theta becomes 0 for 90 degrees. In these three cases, work done will be 0 by that force. Next, concept of energy. Energy is the capacity to do work. So every system, inside the system there will be some energy. By doing work we can increase the energy. If system does the work, energy will get decreased. By doing work on system, that is object of interest, we supply energy to it. And if system does work on us, it will supply energy to us. So energy is an internal thing, work is an external thing. Both are equal as per our definition is concerned. Energy is capacity to do work. Both are measured in joules. 1 joule is SI unit. In CGS unit it is 10 to the power of 7 ergs. This is to be by hearted. Work energy theorem. If multiple forces are acting on an object, if all of them are trying to do work and all the forces, if you add it, you get a net force. That force, when it does work or combination of all works, will give you change in kinetic energy of the system. For example, you can see that net work done by all forces is equal to sigma F into S. Net force is mass times acceleration. You separate acceleration and displacement. We know that AS is equal to V square minus U square by 2 from kinematics. mv square by 2 minus mu square by 2 is half mv square minus half mu square. That we call it as change in kinetic energy. Now, if work done is positive, that means difference should be positive. Final must be more than initial. We say energy is supplied. Kinetic energy final is greater than kinetic energy. Speed got increased. When work done is negative, kinetic energy final is equal to kinetic energy negative. The difference should be negative. We say energy is released by the system or speed decreases. If both kinetic energies are equal, initial and final, we say work done is 0. In that case, speed neither increases nor decreases. Velocity may change its direction. The motion, what we talk, can be visible form or invisible form. Let us see. The energy of a possessed by a body by virtue of its motion is called kinetic energy. All moving objects, rotating bodies will possess kinetic energy. Fired bullet, moving cat, car, falling stone, rotating fan, rolling ball, all will contain kinetic energy. Kinetic energy is visible form of motional energy. Potential energy, the energy possessed by body by virtue of its position, state or configuration is called potential energy. For example, raised axe will hit more than little less if you raise it. Compressed toy spring, inside the spring if you compress it more, it will come as more kinetic energy later on. Elongated rubber band catapult, more you elongate it, more energy gets stored in it, more motion gets stored in it. So mass at a greater height possesses more potential energy than identical mass at lower height. So this motion can be in invisible form. So visible form of motional energy we call potential kinetic energy, invisible form of motional energy we call it as potential energy. Let us derive expression for both of them. Let us take a mass, apply force from 0, accelerate it to the speed v by pushing it through a distance s. Then whatever work done horizontally by you, will all the force will make u to become v. That means the force supplied speed to it. Then work done is equal to force into displacement, mass into acceleration into displacement, mass into acceleration displacement. Acceleration AS is equal to v square minus 0 square by 2. So all the energy supplied by the force gone into kinetic, motional energy. So expression for motional energy is half mv square. Now instead of pushing a mass to gain velocity, keep the velocity same but lift it up, lift it up, lift it up and keep it at some other height. In this process, mass is slowly lifted without changing the velocity. Previously we changed the velocity, not height. Now we are changing the height without changing the velocity. Then work done by the lifting force F is equal to mg, which is cancelling the downward weight you are applying in the upward direction. Supply what energy to it? Potential energy to the mass. So now also, previously also you applied force and displacement was there. Now also force and displacement is there. Previously the force helped in gaining velocity. Now the force is helping in gaining the height. So this case, force into displacement, force is mg, which is balancing the weight and height. This will be invisible, stored in the body. When you leave the body from height, it will gain back the kinetic energy. So this combination of visible and invisible forms of energy is called total energy or mechanical energy. It is hard for a beginner to get convinced regarding storage form of energy. Let us take the experimental explanation. Two identical bodies, say chalk pieces, dropped from different heights. Then the body dropped from greater height lands with more speed or more kinetic energy. That is, mass m at more height possesses more energy, which is invisible in the beginning when u was 0 for both. But such hidden energy, motional energy, is called potential energy. In future you will learn that there are three types of potential energies. One is due to gravity, gravitational potential energy. One is due to springs, spring potential energy. One is due to electrical charges, that is electrical potential energy. Now once we understood that energy is two types, visible and invisible motions, add potential energy with kinetic energy, that is mgh plus half mv square. This combination is the mechanical energy or energy of motion, visible and invisible together. Now the most interesting fact, when we drop a body from a height h, decreases in meters and speed increases in meters per second. But there is no direct relation between h and v, that is h inversely proportional to v, h directly proportional to v, nothing exists. But there exists a relation between mgh, not height, combination of mgh, not v, combination of half mv square has a relation. That is, loss in number of joules of PE is equal to gain in number of joules of KE. This principle, in which height and velocity are not directly related, height connected to mg, speed connected to half mv square, have a connection between them. That is, lose in this is gain in this is lose in this, known as law of conservation of energy. So that means energy is not going anywhere. It is just converting from visible to invisible and invisible to visible. This is what we call it as law of conservation of energy. Thank you.